Okay, so we were at this point in last lecture where we have written a program to toggle the single LED. Okay, and we are going to see that next moment, next lab. But what we have done here, so basically earlier we have this port that is either port 0, port 1, port 2 or port 3, and we were toggling that ports. Okay, the bold port, that means I'm going to offer an 8-bit data in either case. But now using s-bit keyword, using this s-bit keyword, what we are doing is we are offering only a single bit of data. Okay, and the location, obviously if data is a single bit, my location is also single bit. So what's the advantage in this case? The advantage, the basic advantage using a bit addressable mode is you do not have to modify, you do not have to modify other bits, or you can say you do not have to compromise the other bits status. For an example, if this bit is 0 1 1 0 0 1 0 1, and suppose I want to change this single bit, okay, not this one, the single bit, in that case I can directly use a bit addressable mode and I can modify this P1.2 instead of modifying all the bits. What happens if I modify all the bits is that it is possible some important bits are lost. Okay, we will see how like what is the some important bits. We'll see that. For an example, if you have a flag register and if my carry is 1 right now, okay, I need it to read, like I need to read a carry flag at some point of time. But suppose I want to modify some other bit in the flag register, in the same flag register. What I'll do, I'll send my data. Okay, I just want to change this kind of single bit and I'll modify all the data. So in that process, it is possible I lost this carry. So this kind of important bits can be lost. Okay? And there are so many SFRs in your 8051 that each and every SFR has some different functionality. For an example, this is a port SFR. Okay, so what do port SFR do? Port SFR will have your input output functionality on the pins. So okay, so input output functionality of the pin is handled by this port SFRs. So the special function of this port SFR is to handle the input and output at the port pins. We'll see that in detail, like how it happens actually. There is an hardware. So if you write something to the port register, actually there is a one hardware module over there. Okay, that hardware module will modify something, and due to that, will either get 1 or 0 at the output. But basically, using a bit addressable mode, you can uh, take care this kind of things. So instead of byte addressable, bit addressable is more preferable in some cases. Okay, the time required for execution is not like different. The time execution will be same, because if I write this kind of instruction and then I write this instruction LED does not equal to LED, even though I have to write a one opcode for that. Same way, if I want to do something with byte addressable mode, in that case also at least one opcode is required. So time execution wise it would be same, but it has a like advantage. You do not have to modify all the bits, or you basically do not have to like uh, bother about what is the status of other bit. Otherwise, what can be done is I can read these other bits and then I can do masking. Okay, we'll see what is masking, how to perform masking. Okay, but that's like a new kind of complexity. You have to first read this status of this register and then you have to make sure only this bit changes. So we are going to do that thing using a logical operator like end operation or on operation. Using that you can do that, but we are not going into that right now. But let's move to our program. There were some things in our program that you might not understand. So this was our last program that we have run, and we have seen that by changing only this number I can modify my time delay. Now there are a lot of things that has to be observed in this program. Okay, so let us observe that thing. We were in bit hurry in last lecture, so let's slowly read this program once more and understand what's the difference. Okay, so initially unsigned character was used. So now that immediate question is, what is like integer and characters? That's the question. Okay, so whenever you heard this, either you heard this integer or you heard character, or there is one more that's float. There are a lot more like that. There is double. So what are all this? What are all this? And why I am interested in this? So this integer, character, float or double are known as data types. They are basically the data types. Now what is a data type? Data type is basically whenever you have some data. For an example, I have this number 20. I have one more number, let us say 250. I have one more number, let us say 3500. I have one more number, that is 10.15. So what's the difference between these numbers? So here, if I want to differentiate this number, I can say this number. Right now I am discussing this in form of decimal. Okay, like these are decimal numbers. I'll move it to the next stage, then we'll discuss about hexadecimal, but right now I'm discussing about decimal. So let's see what's the data type. So data type is basically um, a characteristic of a number. So you can see this number or this number or this number can be characterized as whole number. Okay, there is not a fraction part, but this one is a fractional number. Okay, or you can say it has some point and then it has some data. Okay? But these are real number. Then what about this 10.00? Again, this is a fractional number, though 0.00 value is 0, but if you want it along with 0.00, you have to store it in along with 0.00. That's the thing. So this, you can say these are the fraction number and these are my whole numbers. Okay, now again this can be again subdivided into the size. For an example, I can say this 20 only requires 2 space to be written. This requires 3 spaces, they require 4 spaces. Same way, if we are discussing hexadecimal, at that time in any programming language, all the programming language basically works on binary. Okay, so the base is binary basically, and then uh, like for that binary, you want to handle the binary. Okay, though we write it in decimal or any other octal or hexadecimal, we write it in that form. But actually, at the other end, it would be handled in form of binary. So there are predefined sizes, like predefined sizes of what? Predefined sizes of the number. So what does that mean? That means, for an example, a character. Let us have a character. Data type is character. Let us say data type is character. So people say the character size is 8-bit. Okay. So generally character is 8-bit. Like this character is not related with A, B, or C or D. Okay. I am not discussing about this character. I am discussing about data type as a character. Character is a data type. So generally character is 8-bit data type. Okay. What does that 8-bit data type means? That means it have 8 bits of storage. So if I declare some variable that this variable is character type, that means that variable can only has 8-bit of space. Okay, so you can accommodate any number that is 8-bit long. That's the meaning of character data type. Okay, so if I say my character is I, that means your character I can have only 8-bit. Okay, now, does that mean it can have 7-bit? Yeah, it is possible it can have 7-bit of information, but if only 7-bit information is present, automatically it will take one more bit, that's 8-bit as a 0. Okay, so your number looks like this in that case. So if your data is less than 8-bit or equal to 8-bit, then you can store that data inside your character I. Okay, now there is one more thing. There is one more thing. Is there any question?
No, sir.
Okay, so there is one more thing. That's the maximum size of the your data. Your size of data can be max, it can be 8 bit. Okay, so then what is max 8 bit? Like what's max 8 bit? So this character data type can be declared in two forms. Okay, why two forms? Because we know sometimes we do operate on signed operation and sometimes we perform unsigned operation. So now how can it make the difference? So if you perform it signed operation, we know that your processor or controller has one space reserved for sign. D7 bit is always a sign bit. So here, if it is 0 or it is 1, it represents a sign. So here your data can only be 7 bit longs. Your actual data can only be a 7 bit longs, but if it's unsigned, in that case, you can use all your 8 spaces for your data. So in case of your unsigned operation, your data would be of 8 bit size. Okay, let's make it bigger. So here it's 8 bit size. Now what is so important in this size, like how this size can do anything or how this size is related to us? So this size is related to us in form of what data it can store. Okay, if there is a 8 bit space, the minimum number that you can accommodate in this 8 bit space is 000. Okay, if I put all 0, that's the least number possible in your 8-bit data. Okay, and if I start to increment it by 1 1 1 1 1, at the end I will reach at this number, and that number would be all ones. It is 0xff. In decimal system it is 255, and that makes the point. This is the important part. Okay, so if you have a variable or if you have a data that exceeds 255, that is larger than 255, okay, it's larger than 255, you cannot use this. That's here. Why? Because the maximum number to hold inside this register is 255. Now let's see an example. What happens if I do this? Okay, let's say my value of I, my character I is that. Okay, character I is that. Okay, data type of variable I is character. Okay, it's like this. Data type of variable I is character. I can redeclare this. Let's say I am storing a value that is 1205. That's the value. Suppose I am doing this. Okay, size is character. So inside 805, like we are writing, actually this is right, we are writing a C program. C will automatically convert it to assembly level program, and then at the later on it can convert it to be hex program. So what happens when C converts your 8051 to assembly? Whenever it see a character I, what it will do? It will allocate a space for register I, which is 8 bit long. So what will happen now? It will try to send this data inside there. So what actually will happen? It will send this number. Okay, 0 0 1 0 0 0 0 0, and then 1. Sorry, it should be 0101. This is the number. Okay, 1205. This is 1205. This is number 1205 in hexadecimal. So what will happen? Actually, this is only 8-bit long space. So actually it will discard this number, the other part, and it will store this LSB inside your I. So your I will become only 05. Although you have sent 1205, it will only store number 5. And that's where your problem starts. Because what you assume is you have stored 1205. What 8051 has done, it has only stored 05. This is not actually a problem of 8051. This is the problem created by you by making a wrong selection of the variable data type. Okay, and that conversion is automatic, like C to assembly and assembly to hex is automatically. So you never came across this error, like you never understand this, that this has been happened. But if you are programming in assembly at that time, you can have taken care of this. But right now we are programming in C, and whenever you accidentally write character I, then also whenever a conversion is done in assembly, at that time I will only have 8-bit long space. Now let's see this with an example. I'm going to give you the same example of 1205. We'll try to store 1205 and we'll see what happens. This is the program, and I'm not going to bother this program. So what can I do is I can remove this program from here. I put it in Word because we will be coming back to this program at the end. And here I am writing only 3 lines. The first line is my unsigned. Okay, why I write unsigned? Because I want to have my I as an unsigned operation. Okay, because we were discussing about unsigned, so I have unsigned variable I. So why you have to specify unsigned? Because if you do not specify unsigned, okay, automatically it will get unsigned. But in case of you have to use signed, at that time you have to specify signed, otherwise it will be unsigned. So rather than realize like left this opinion of K, what we'll do, we'll specify whether it's unsigned operation or signed operation by writing it. Okay, so if I write unsigned space character space I, this is how I can declare a variable I in unsigned character data type. Okay. So right now my I is unsigned character data type. Then I am going to write void main, okay. And then I'm only going to write while one. First let us write I equal to 0x00. Okay, and then I'm writing I. Not do that. Directly write 1205. And then let's write while one. This while one is just to have make sure that no errors occur. Otherwise what will happen is there will be an error. Not error, there would be a notice. I know that what happens, so I'm not bothering it. Okay, this is the only operation. I'm just trying to assign value of I to be 1205. Now let's see what happens. Okay, I'm going to run this program. And here in this window you can have my your variables. You can watch your variables. How to watch a variable, that's very important. See, there is a watch window. If you download the kale, you'll see this window over here. Name is watch window. There is a kind of window symbol with let me magnify it just so you can see. Okay, so see, this is the symbol. Okay, this is the symbol, and using this symbol you can create a watch window. So as soon as I press this, a watch window will be created. So I am pressing this. So here you can see your watch window. Let me zoom in here. So here it is my watch window. Watch one is the name of window where it appears on your right hand side bottom. Okay, so this is my watch window, and here by double clicking here I can enter my value that I want to watch. So I want to watch the variable I. So I'll click I and I'll press enter. So right now I is 00. Now let's run the code and see what happens.
No next text.
Now let's see what happens. I'm going to run this code. Okay, I'm going to single step inside and we'll see what is the value of I. That's where I am interested. See, what is the value of I? Again, let me open the magnifier app. So you can see the value is only 0x05. So this is the thing. What I have to try is 1205 and what I get is 05. And that's where your actual trouble starts. Now I'm going to give you one more example, like how this error can be so important. Okay, so now we know how to toggle LED. Okay, so what I'm going to do, I'm going to have an LED, let us say S bit LED equal to 0x95. What it will do if I write S bit LED is 0x95? Anyone can answer? S bit LED is equal to 0x95. I've written this line. What it will do? I'll expect the answer from Nihir, 14 number. or the 15 Nishita, or 16 Trushen? You three can answer. 14, 15, or 16, anyone can answer. What's the question is, what will happen if I write S bit LED equal to 0x95? I am uh, tagging which pin or which resistor, that's the question. See, if you do not understand these things, 8051, like nothing will work. If you do not understand what's S bit, nothing will work. So you have to answer this. Either Nihi, Nishita, or Tushin can answer. At least unmute yourself so I can understand, like you are listening, actively participating in the lecture. If Tushin is there, Nishita is there. I don't expect Nihi is there. Nihi is also there. Okay, anyone can answer, like any one of you can answer this question, like what like what will happen if I write S bit LED equal to 0x95, or which port or which pin or which bit I am accessing right now. Okay, anyone from the class can answer this? What will happen if I write S bit LED equal to 0x95? Satish,
Only one bit.
it's a one bit, okay, correct. But which resistor I am accessing right now, Satish? Can you answer that?
P1.
P1 is the resistor, correct. And as I have written S bit, so it's only one bit. So which bit of P1 resistor? Can you answer that? Okay, let me explain one more time this thing. See, here you have this kind of arrangement inside your P1 resistor. See, this is my port 1 resistor, this one. So 90 is the address, but this is a byte address. So if I write SFR, then and then this address matters. If I write S bit, in that case, this address doesn't matter. If I write S bit, which address matters? This address matters. 90, 91, 92, 3, 4, 5, 6, 7. So you see 95. So I'm discussing about this pin. But which is this pin? Okay, so he was correct. Satish was correct. This is port 1. Okay, but which pin of port 1? So if you have difficulty in naming this pins is usually named after the port itself. So this pin is P1. If it is 0th bit, you can say this is P1.0, this is P1.1, P1.2, P1.3, P1.4, and P1.5. So I'm accessing P1.5 bit of port 1 resistor, I can say. Other way, I can also say I am trying to access port pin, not bit, port pin P1.5. Because why I'm saying this, because whenever you do something over here, that will be reflected in terms of output at your port pin. So this is a resistor, this is a bit where you can store something, but that would be reflected at the port pin P1.5. That's the reason uh, why we say it like that. Okay, so what I have done here is I have added one more line, S bit LED 0x95. So I'm going to toggle this 95 pin. So let's see how to toggle that. We know how to toggle that. You can use your for loop. Why we use for loop, or what's the importance of for loop? Let us say time being, I am writing here I less than 10. Okay, and I'll write I plus plus. I want to show you something. That's why I'm doing this. This is the this is the current bracket. So whenever you write for loop, you have to use your regular bracket, or you can say your chord bracket along with for loop, and the body would be written inside your curly bracket or curly bracket. And here I'm going to write LED does not equal to LED, or you can say LED not LED. So this is the program. I'm going to build it by pressing F7. No error, no warning. I'm going to run that program. I'm going to debugging session by pressing Control F5. And now what I'm going to do is I'm going to single step this. So what will happen? I'll start with 0, then I'll be increasing continuously, and meanwhile you will say the status of LED over here. So how to add this? Go to this logical analyzer, click on that setup, and then from here you can click on this new and then write LED and press enter. As soon as you do that, you will see LED with 0 and 1 mark over here. Okay. So see, now I am going to single step this. So what will happen? Okay, see, for each step your I will start with 0 0, which each step your LED will be like increasing. Okay. So what does it mean? The time frame is increasing. To run this instruction, it will require some time. During that time, your LED was still 1 because we are not changing right now. The status is not changing right now. So time being, it will go like this 1 1 1 1 1, and then a point comes where it goes to 0. Okay, so let's see that. So now you can see I value is increasing. See, it is 0 1 right now. Again, I'll click it. Again 0 2 0 3. So it is executing for loop. So you can see this green line is not going ahead. So it's actually going inside like this. It is looping inside your for loop. Okay, I7, 8, 9, and A. Okay. Now see, as soon as A comes, so A less than 10, it's wrong. Like 10 is that, but 10 is actually A. You can see 10 is equal to 0x000 A. That's the point. So A less than A, it's not correct. A is equal to A. That's correct. So it has broken the for loop, and you can see your program counter has moved ahead. Okay, and right now it is on LED equal to LED. As soon as I single step, your status of this LED will change. Okay, I'm zooming out a bit. You can see a fall over here now. Okay, so this was the fall. Okay, so now you can see the status is 0. Again, it will go back up. It will start your I will again start with 0. It will again like go up to 10, and again LED will change the state. So this is how you get the waveform. Okay, so this is kind of your square wave. And if I continue this, it will be continuing totally. Now, what's so important in here? By changing this number, you can increase or decrease this time delay. Right now, the delta is 16 microsecond. But if I change this number, let us say I make it 250. Let us say I make that number 250. Sorry, Control F5 to stop the debugging session. As soon as you debugging session, you can modify it. Again, build the program by pressing F7, and again debug. Okay, now again I'm going to run this. Now what I'm going to do is I'm not going to like I'm not going to single step through this because 250 is quite a large number and I cannot do that for 250 times. So what I'll do, I'll use a breakpoint. What's a breakpoint? Breakpoint is kind of a break to your program. So if I add a breakpoint here, what will happen if I run this program using this continuous run button? It will end at break. It will break at the this place where I add a breakpoint. So how to add a breakpoint? So right click on this and you can insert a breakpoint, or you just have to double click over here. Okay, just single click over here. So as soon as I single click, you can see this red button. That's a breakpoint. Okay. So if I run this program now, what will happen? It will execute this program from this point. It will stop when this line is reached. So it will execute only for loop. That's the point. Okay, so you can do it like this. So you can see your value of I is FA. Okay, so the condition is 0x 00 FA. 250 is FA actually. So that's stop when I becomes 250. And now my LED will change the state. Okay. You can see it over here. I'm going to do this one more time or two more times. And this is my time delay. So by just changing the size of my variable I where it can reach, I can modify my delta. You can see it's now 0.3795 millisecond. That's almost 379 microsecond. Earlier it was only 6 microsecond, 15 microsecond. So by changing the size of this I, you can actually vary the delay time. Okay, but this is not the control delay. If I want to have 250 microsecond delay, I cannot do this with this program. Okay, by just writing 250 over it does not make sense. Like the delay would be 250 microseconds. It does not work like that. We'll see how it works, but for loop is not designed to have a specific time of delay. Okay? But generalized delay can be provided by it, like it can have some amount of time delay. The larger the number, the larger the delay. Now keep this number in your mind. Okay, keep this number in mind. What happens is it's 0.37 millisecond. Now what I'm going to do is I'll just change this character with integer. But before doing that, let me introduce integer first. So what is an integer? So integer, whenever you use integer in case of your 8051 or K, your integer, let me write it out. Okay, what I'm going to do is I will have integer. Let us say I have integer. Integer is 16-bit long. What does that mean? It has 16 spaces like this. Okay. So it has 16 spaces like this. So your number, if it's unsigned number, it can have 16-bit long number. The number range will start from 0x000 in terms of hexadecimal up to 0xFFF in hexadecimal. This is mean max range. Okay, and if you discuss it in decimal, it start with 0 and it will start up to 65535. What is this? This is just conversion from hexadecimal to decimal or to binary. Okay, same way binary would be all zeros and all ones, the max. Okay, what about sign? We'll discuss about sign later on. Okay, again, sign would be 1 bit of your sign plus 15-bit of your data. Okay, we'll see how what is the range. We'll see that. But timing, let us say your integer can have a 16-bit long outputs or 16-bit long data. So now what I have done is I have just changed my operation unsigned integer instead of unsigned character. Okay, what was the time delay we were getting? The time delay using my character I along with 250 size, I was getting 0.37 millisecond delay. Okay, now what we have changed, we have just changed this integer. I have just changed this character to integer. Still 250. Okay, 250 is in between this. I can use integer as well. Is there any issue using integer? No, there is no issue. Because still is in between that. Then why I insist to use a character and why I use to insist integer? Like all the place I can use integer. Correct? I'm correct or not? Instead of having two different data types, I can use single data type integer at all the place. Would it be fine or not? I need some responses. Would it be fine or not? You have to just say yes or no.
Yes, sir.
Yes, sir.
It would be fine. Okay, no issue. Like from naked eye, you can see no issue. Even I would do that because uh, using two different data types for variable, and then both the variables can have same like the other one, that integer one have can larger range, and even the ones which been covered by character that can also be included in integer. Then what's the issue? The issue is in programming. With naked eye, you cannot see the issue, but I'm going to show you the issue. Okay, what I have done, I have just replaced the character with integer. All the other program is same. Just I have changed this thing. Here I have just written integer. I'm going to run this program. Okay, first I'm building this. Control F5 to start debugging session. And again, no changes in here. I'll just run this program through. Okay, and let's measure this size of delay. What's that? That is 0.757 millisecond. What the delay size is? 0.757 milliseconds. Now, how this miracle happened, like how it has almost doubled. So how this miracle happened? Can anyone explain what happened? I haven't changed anything. I have just changed character to integer. Still 250 was 250. I was I. LED was LED. For loop is as it is. The other program, the other part of program is written as it is. Then why this change happened? So the point here is this character or integers matter a lot. How does this thing change the behavior of program? Because if you are using a character, your size of the data is 8-bit. Okay, we know your 8051 is 8-bit processor. So whenever you are using a for loop, there is a comparison in between, there is an increment operation, and that all operation would be performed an 8-bit number, so it can done with this using single instruction. But here what happens is this is a 16-bit number. Though 250 does not looks like a 16-bit number, but you have used integers, so it's now 16-bit. Whatever other spaces are there, it will be filled with 0. But now what happens? KL to C transfer is there, so it sees integer. It sees that user needs a 16-bit option or 16-bit variable. So what it will do? It will acquire two 8-bit spaces. See, what is the comedy? It will acquire two 8-bit spaces, like it will separate out two 8-bit spaces, and whenever a comparison operation is there, first it will do that comparison on lower number and then on the higher number. Okay. Now let us see that in example. Let's check what 250 means in hexadecimal. It's 00 FA. Okay, it's 00 FA. So what it will do? It will first it will start with 00. Now I is 16-bit, so it will start with 000. Okay, so I is equal to 0 means this number. It will go to 01 is equal to 1. Okay, this is a decimal and this one is hexadecimal. That's 250. Okay, so 250 is actually written inside here like 00FA. So what will happen? What will happen? It will check first. It will check 01 with FA and then it will check 00 with 00. Okay, and if both the condition match. Okay, so there are actually two instructions executing to operate on the same amount of data. So here still 250 is 250, here also 250 is 250, but here the data size, okay, the size of variable was only 8-bit. So controller knows I can do that using one single instruction only, either increment or comparison, both can be done in single instruction. But here that 16-bit number, so it has divided that two number into 8 bits and it will perform increment on this both number one by one. Okay, if there is this one is full, it will pass on to increment to this one. And comparison is also done between these two because it cannot compare your 8051 not compare this number directly with this number. Why? Because your 8051 is only 8-bit processor. That means it cannot process 16-bit data, which this is. Okay, so it cannot do this. That means it has to do so, like it cannot do this in single sort. That's the thing, it cannot do it in single instruction, but it can do it, or user can have a program that will separate out this 16-bit operation into 8-bit operations. So here the size of program would be double. The C programs look same, C program looks same, but your assembly code would be double size. Okay, and at the same way, if the size of program is doubled, your time will also be doubled, and that's the only difference that is important as in programmer, why you use character and integer separately. So if you do not require integer at all, do not go for it. What will happen? Like still 250 can be included in integer or character. It's great. But what's the issue? Your program will be bigger. So you will require bigger memory to accommodate that program at your age or at your understanding of 8051, or while we program 8051 at that time, that's not so important. But if you go for a system designing task at some company, okay, at that time this creates an issue. Okay, do you like a mobile that works slower? Anyone would love the mobile that works slower, or anyone love the device either be it a microwave or be it a washing machine. That's kind of, you press something and it takes some time to act. So to make the system efficient in terms of the size of program and the efficiency in terms of time, you should use the variable, or you should use the variable correctly. Okay, what do a correct variable means? If you do not require, your data is not going to be larger than 250, do not go for integer. Okay, if I can accommodate a data in character, go for character data type only, and that's the point where your difference will start. Okay, if you unnecessarily go for integer, your program would be same, sorry, your like data type would be same in front of screen, your C program is same, but at the end assembly program is different. And that's why assembly program is important. That's why we learned the assembly programming, like how to perform an assembly level programming. So now let's check that whatever I'm saying is correct or not. Okay, so let's check that. First, I'm going to use a character over here. I'm going to build the program by pressing F7, and you can see here data equal to 10 and code equal to 29. This code equal to 29 is important. Okay, right now it is character and code size is 29 bytes. 29 byte is the size of code. So to accommodate this all codes, you require 29 byte of space. That's the thing. What I'm going to do, I'm going to have integer over here, and I'm going to again build the program by pressing F7, and you can see your code size increased to 38. Why it has increased to 38? Because here you are insisting your I to be 16-bit, and that's why this for loop will take longer time to execute, because it would have 16-bit comparison and 16-bit increment operation. That's the thing. Okay. Now, same way, it has changed here code, same way it is changing the time of the operation, and we have seen that. That's the proof why you should not use the data type that you do not require. Otherwise, even I can go with float. Okay, I can do this thing in float, no issue in that. But I'm not going to use float. Why? Because if I use float, okay, let's check this using float. What happens? Sorry, it should not be like this. It should be like this. See the code size. How much? It's more than 15 times of the previous one. Okay, so that's matter a lot. That's matter a lot. That was the point that I'm making. Otherwise, just for your understanding, otherwise, what you can do is, you can remember this range and size, and if your data is not going to be crossing that size or that range, you can use the data type. Okay, now one more point that I want to show. See, I'm going to do this thing. I'm going to use a character over here, and I'll try to make this to 500. So character is only 8-bit long, and this variable I'm comparing with it 25000. And now let's try to build this program. Okay, and I'm going to run this program. See what happens. I'm going to remove this breakpoint. Okay, I'm going to zoom out a lot, and I'm going to run this program. Your LED will never toggle. That's the point. Your LED will never toggle. Now what happening here? What's happening here is your I'll start with 0. Okay, but with 0, it is 0x00. You can see here it start with 0, only 8-bit number. Okay, so what is happening inside here right now is your I will start with 00. I is starting with 0x00, it will go 0, 1, 2, 3, it will reach up to FF. Okay, but I am comparing with what? I'm comparing it with 0x9c4, and it would be always less than. Now what happens once it reach FF? What happens? Again it will try to increment this by 1, and this resistor is only 8-bit. What will happen? It will have answer like 100, but this one cannot be stored, so it will only store 0. So again it will go back to 0, and again it will start. So this for loop, although it is correct, written correctly, but as data type is wrong, it will never going to break, and that's the thing. It's not breaking. It cannot be able to break this loop. Why? Because your I never go beyond 0xff. Okay, and I am comparing it with 0x9c4, and that's never happening. That's why this loop is wrong. So this is one more point. This is one more point where you have to take care which data type you are using. Okay, so the data you comparing with, your data you are going to have min max. Depending on that, you should use your variables. Okay, and y selection should be done. So now let's quickly see the range of different data types. Okay, and what I'm going to do is I have this data type over here. I'm going to write my size of data type, okay, and mean max range, okay, or you can say range in general. So first we'll discuss about unsigned integer. I should write it correctly, like that's not the good way. Let's prepare a table and it would be more clear in that way. Here, let us say I have my data type. Here I have my size of data type, and here my range. You sometimes you might see one more line over here. Let's say this. Where is it? Insert to the left. One more line you can see is the scope. So what does this mean? Let's understand with unsigned integer. So first data type is unsigned integer. What is the size? 8-bit. Okay, size is 8-bit. What's the scope? What do a scope mean? Scope means how many numbers of value it can have. Okay, how many numbers of value? I am not discussing about which value it can have. What is how many numbers it can have? So it can have, it's 8-bit, so it can have 2 power 8. It can have 2 power 8. Okay, so 2 power 8 is 256. So scope is 256. It can have 256 different values, unique values, 256 unique value. But which are that values? So your values will start with 0. It will go up to 255 in case of decimal, or you can say 0x00 up to 0xFF in case of your uh, so you can say it's a hexadecimal. This is a hexadecimal. Okay, same way you can have signed operation. Signed integer you can have, but in case of your signed integer, what values you will have is, it's auto capitalized. Again, your size, as it is integer, your size is not going to change. But what's the scope? Scope is still 256. But which values it will take? It will take the values. It will take the values. Now a negative as well as positive values will be part of that. Okay. So you can say a negative value is this, that ones which start with 1. So negative mean is this, and negative max is this. Okay, this is negative maximum and minimum. Same way, positive will start with 0, 0, 0, 0, and positive max would be this number. Okay, so actually, if you write the range would be in two parts. Like it would be 128, negative 128, positive 127. That's the range. Okay, but in terms of hexadecimal, again it would be 0x00 to 0xFF. Okay, but what would be the different? The first 0 to 07 numbers is related to positive. So let me subdivide it in like this. It would be 0 to plus 127. That means it is starting from 0x00 to 0x. That's how your range works. And same way for your negative 1 to negative 127. Negative 127. It will have the number starting from 0x80 to 0xff. It should be 7f. So this is the range. For positive number, it will be ranging from 0 to 7f. Why? Because these are the range. I can start with all zeros and all 7 ones. So only 7 bit are using as a data. So what with 7 bits you can consider this number. Now 0 is considered as positive number and 0 is represented as 0 0. Okay. And negative 1 to negative 127 is represented in this form. And we are not going to use sign, but this is important information and that can be asked in the MCQ. So you have to remember this. And if you do not want to remember this, how you can calculate this? So we use calculator to calculate this. You know 2 power 8 is the number. Okay. So if it's positive number, minus 1 is the range 0 to 255. Okay. So 2 power 8. I need a scientific calculator for this. So a 2 power, where is power? Where is power? Yeah, 2 power 8 is the number. This is the scope. Okay. If it is unsigned, just do minus 1. This is the maximum and minimum is 0, obviously. Same way, if you have 255 and if it is a signed operation, divide it by 2. Okay, this is the minus 128 would be range, and if you have minus 1, okay, 127 would be there. That's the positive side. Okay, sorry, it's 128 minus. Okay, that's right. Same way, and the most important thing, that's not integer. This is a character. Guys, you can stop me wherever I write something accidentally. So this is the actual thing. Same way for unsigned integer is missing. It's unsigned. GL. Here I will have a 16-bit long numbers. Scope is 65536, and your number can start from 0. Let me write 2 here, otherwise it will create a chaos in your mind. We'll start with 0 up to 65535. Okay, so 65536 minus 1, that's the maximum possible number. In terms of your hexadecimal, it will be ranging from here to 0x FFF. Okay, but if it is a signed operation, if it's a signed operation like this, in that case your number will be, again, now I have to calculate. See how I am going to calculate. I know the number is 65536 divided by 2. Okay, so you ended up sorry, 65536 divided by 65536 divided by 2. So 32768 is the number. So my range will start from negative number, that is 32768, and up to 767. Okay, whatever is the negative number, minus 1 is the positive number. And I'm not going to write this range, but it will be ranging from 000 to FFF. Okay, if you want that, it would be like this: 0x 7 FFF is maximum number in case of positive maximum, and your negative maximum would be 0x 8000. That's the negative maximum. Now do not mislead this. This is maximum of negative, but minimum of negative is 0 FFFFF. Okay, that's why I'm not writing this. That is the issue. That's why I'm not writing it. So this is signed. What about float? Your float number are never like signed numbers. Okay, like float is all together different thing. So float is 32-bit size, and it's not saved in case of like, there's a different system to store the float. So I'm not discussing about a scope and the range of this float. Okay, there is two like according to IEEE, a float number would be divided in two parts. Mentee and mentee is the name, and it would be stored in terms of mentee and mentee. So 15 bit is related to mentee and then other 16 or 17 bit is for mentee. So that's how it is stored. Like in terms of 10 to the power, it is stored. Okay, so if I have 0.4365, then it would be algorithm is there how to calculate that number in terms of floating number. That's what not we are discussing. We are not discussing this because we are not even going to use the float number. Okay, so this is the important of signed unsigned. Okay, and this is the size of that, and this is the scope of that. Okay, so if your data is it when between 0 to 255, always go for character. If your data is exceeding that, go for this range. And there is one more. Okay, data type related to your embedded C programming only. That's only 1 bit of data, and the scope is only 1, and the range is 0 and 1. Okay, so you can have one single bit of data. Okay, I can access this kind of data. We will be having a data type bit at some point of time. Okay, so we'll stop here for the today's lecture. If you have any question, you can ask or you can leave.